Okay, everybody. Today we're going to finish up chapter 5. It only has 2 sections. This is the second one. The first one was addition, subtraction of integers. Now we're doing multiplication, division of integers. We're going to be using mostly three models: the chip model, the number line, and patterns. And remember, what is multiplication? Turbo addition. It's adding things a lot faster. So let's look at the chip model for multiplication. Right? So we have 2 types of chips. We have to have chips for positives. We'll use yellow chips or blue chips. And then for negatives, we'll use red chips. So remember, this is moving to the right. These move to the left of the number line. So we could use these chips throughout the whole thing. So how do we use chips for if we had 3 times 2? Typically, the way we look at this, the first number is the number of groups. The second number are the elements in each group. So what this says is we have 3 groups. 1, 2, 3. And in each group, since it's positive, we have a yellow chip, a yellow chip, a yellow chip, yellow chip. So there are 3 groups and 2 columns, or 2 in each group. Count the number of chips. We have 1, 2, 3, 4, 5, 6. As I said earlier, remember, it's turbo addition. So what this is saying is 2 plus 2 plus 2 equals 6. That's the way you would represent it. How about if we had a negative number in there? Say we had 3 times negative 2. So we have 3 groups. Now they're negatives. So it's red chip, red chip, red chip, red chip, red chip, red chip. And we add those up. We get, there's 6 chips and they're red. Reds are negative, so it's negative 6. What if they're both negative? And we have 3 groups of 2 chips. They're both red. So if we just take that, we have negative 6. But because that's negative, if the number of groups, this means the opposite. So the opposite, it means just change the sign. Negative and negative is a positive. So the answer is positive. Notice what it says here is we have red chips. They change color. So what happens is they all become yellow chips. Likewise, if we just had negative 3 times 2. So we have 3 groups of their 2, so they're all positive. But this one makes them opposite. So we change their color. Red, 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 red. Now, if we count those, we have 6 red chips, and reds are negative. So we get -6. So if we start with negative red chips, so if we start with red chips and change the color to yellow, or start with positive chips and change them to yellow, or to red, I mean, and then that's how that would work. All right, so that's how using chips would work. And after the kids learn that, okay, I don't need the chips, I can just use Y and R, or blue and red, or whatever colors you choose, then that would work. How about look at the number line? The number line model for multiplication. Here are the rules for using the number line. Always start in 0. Remember, that's in the middle of your number line. And always face to the right. That's the positive direction. So here's your number line. So I start at 0. And if you have a person, they're facing to the right. Second rule. If the number is positive, move forward. If the number is negative, move backwards. So let's see here. So we have example is person. Let's say we had 2 times 3, or 3 times 2, doesn't matter. Remember, this is number of groups, this is number of elements. We have 2 groups of 3 steps. Since they're both positive, to the right. So in this one, we have 0, 1, 2, 3. That's one group. 1, 2, 3. That's the second group. So 2 times 3 equals 6, where you end up. All right, let's look at another example. -3 times 2. Well, this thing says we have 3 groups going in the opposite direction, because it's negative, of 2 steps each. We have three groups of two, but they're going in the opposite direction. So he's facing this way, remember? So he has to go backwards. That's 1, 2, that's 4, and then 1, 2. That's 6. But it's in the negative direction, so the answer is -6. -2 times -3. We have two groups going in the opposite direction of backwards, because this is opposite direction. This is backwards. So the opposite of backwards is forward. So the opposite of backwards is forward. Backwards of 3 steps each. So we have two groups of 3 steps, and the opposite of backwards forwards. 1, 2, 3, 4, 5, 6. So the answer is +6. That's using the number line. Okay, you use a number, you can show a number like this, or have the kids stand up and walk around. All right, the next one is patterns. Multiplication. All right, so how do we use patterns? Good. Remember, multiplication is repeated addition. 3 times 2 is either 3 plus 3, the number 3 twice, or 2 plus 2 plus 2. 3 groups of 2. They both equal 6. So let's look at patterns here. But one way to look at patterns is, let's use a chart. We're looking at 3 times 2. So make a bunch of these rows. So we have this time 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. 3 times 0 is 0. But we're multiplying by 3. So what do we notice? That as each of these numbers get smaller, this is changing by 3. It's subtracting 3. So if I go down one more, I subtract 3, I get -3. If I do -2, I subtract 3 more, I get -6. -9, and -12. So we notice here is whatever we multiply by, if it's positive, we notice that A positive times positive is positive. Positive times a negative is negative. Anything times 0 is 0. This is, since they're all changing by the step of -3, this is called an arithmetic sequence. We can follow this procedure down, 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 down forever. And so that's using a pattern. So you know, you're looking for 3 times 2. So let's just try it. Let's create a pattern. So we start 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 is, and then down. So no matter what you give me, if 3 is positive, 2 is negative, or 2 is positive, answer is positive. If 3 is positive, 2 is negative, answer is negative. But because of this, because we're going to learn the commutativity property, 3 times -2 would be the same thing as -3 times 2, which is the same thing as -3 times 2. So if one of the numbers are negative, then they put that negative out in front, and we just multiply the numbers and leave the number negative. If both of the numbers are negative, we could take both of those out in front. Take this one out, take that one out, put it in front. Negative times negative is a positive. So that's using some of the properties that we're going to talk about shortly. All right. So speaking of that, let's talk about the properties now. Of multiplication. All right, so here are the properties. This happens, we only have properties we had for addition, and now we have for multiplication. We don't have them for subtraction or division yet. Those are separate rules. All right, so the first property. Well, I'll do it next. Okay, so the first property is the closure. Let's just talk about closure first. We say X and Y are integers. If I take two integers and multiply them together, their product will be another integer. 2 times 3 is 6. They're all integers. -2 times 3 is -6. They're all integers. And same thing of 2, -3. So that's closure. It means if I take two numbers, multiply them together, their answer is going to be also an integer. The next one is the commutative property of multiplication. What this one says is if I take two numbers and multiply them together, it doesn't matter in which order I put them. 3 times 2 is the same thing as 2 times 3. They both equal 6. The next rule of property, the associative property of multiplication. Well, remember, okay, to commute means to move, which is what we did. We moved them around. Associate means to group them together. This one's saying is if we had three numbers and we multiply them together, X times Y times Z is equal to X times Y times Z. But because nothing in our universe can do more than two numbers at one time, we have to tell our brains which ones to multiply first. we can multiply first two together and then the third, or the second two, then the first. They can give you the same answer. 3 times 4 times 5 equals 3 times 4 times 5. 3 times 4 is 12. 12 times 5 is 0, 6. 4 times 5 is 20. 3 times 2 is 6, and put a 0. This just shows you a better example of why the associative property is important. No matter if you have a series of numbers and they're all multiplied together, I could pick the numbers that make it easier for me to complete my process. The right side is by far. This side is a lot easier than this one, because this one I do 5 times 2 is 10, carry the 1. 5 times 1 is 5 plus 1. So there's more moving parts equal more chance of mistakes. So that's a perfect example of why the associative property is important. You could put the parentheses around any pair of numbers. The distributive property. Of multiplication over addition. That's the formal name of it. What this tells us, if we have numbers or letters inside a parenthesis multiplied by a number in front, the number in front is called a coefficient. What this says, because it's a times x plus y, whatever's in front multiplies to whatever's inside the parentheses. A times x is ax. Positive times positive is positive. A times y is ay. And we could do it either direction, either way. We could do, if we can have it this way too, where everything inside the parentheses multiplies by a. So x times a is ax. Positive is a positive. Y times a is ay. They get to be the same answer. So that's the distribute. The coefficient distributes to everything inside there. The next one is called the identity property of multiplication. What the identity property says is this. Is there a number that allows x or whatever number to keep its identity, keep it same? So in other words, x times what gives me x? Does it keep its identity? 3 times what equals 3? Right, 3 times 1. So x times 1. 1 is the identity of multiplication. Anything times 1 is itself. Anything times 1 is itself. It doesn't change. And the last property is a zero property of multiplication. The zero property of multiplication. Anything times 0 equals 0. X times 0 equals 0. -3 times 0 is 0. So those are those properties. All right. Let's start a couple of theorems here that come from those guys. Theorem 5-6 says, for every x, -1 times x equals -x. For every x, doesn't matter what it is. -1 times x gives me -x. So if x equals 5, -1 times 5 is -5. Okay, but now what if the x is negative? That's another theorem. For every x less than 0, -1 times x equals x. So -1 times -x equals +x. Because a negative times negative equals positive. So -1 times -5 equals +5. So -x times -y equals +xy. All right, there's a couple more properties now that deal with signs. Or not properties, but theorems. Well, one more theorem. 5.8. Let x and y be integers. Remember, integers are positive numbers, 0, and negative numbers. It goes everywhere from -infinity to +infinity. So it says here, here's the first one. -x times y is the same thing as -x times y. -x times -y equals +xy. Ax minus y equals ax. Positive times negative is negative ay. X minus y times a. X times a is ax. Negative times positive is negative. A times x times y, or y times a is ay. So it doesn't matter which direction you go, it's still the same thing. All right, so that just shows us that this distributive property also works in this thing. Let's take a couple examples. -2 times x minus 2. So this number has to go to both of those. So negative times positive is negative. 2 times x is 2x. Negative times negative is positive. 2 times 2 is 4. So there's the answer. X plus y times x minus y. This is a pretty important one coming up. because it's got a name and everything. So we'll look at that. So everything in this first parenthesis has to multiply, because it's multiplied to everything in the second. Positive times positive is positive. X times X is X squared. Positive times negative is negative. X times Y is XY. Positive times positive is positive. Y times X is the same thing as XY because of commutativity. Positive times negative is negative. Y times Y is Y squared. These two, XY, XY, are the same numbers but different signs, so they cancel each other out. So X plus Y times X minus Y equals that. This is called the difference of two squares. For easy reasons. The difference means subtraction, and they're both squared. So let's look at this. Here's an example. X plus 3, X minus 3. X times X is X squared. Positive times negative is negative. X times 3 is 3X. Positive times positive is positive. 3 times 3 is 9. Let's write this one. Positive, positive is positive. 3 times X is 3X. And then 9. The 3's cancel, so we're left with X squared minus 9. This is X squared minus 3 squared. X times X, 3 times 3. Sorry, but they're making noise outside the room and I just got distracted. They closed the door. We'll do a couple more examples. Four plus X, 4 minus X. 4 times 4 is, okay, 4 squared. Let's do it this way. Positive times negative is negative. 4 times X is 4X. So that's done with this one, because I've done them both. Positive times positive is positive. X times 4 is 4X. Positive times negative is negative. X times X is X squared. These guys cancel because they're the same thing, different signs. So we have 4 squared minus X squared, which is 16 minus X squared. And there you have it. Also works if we have negative numbers in there. So negative and negative is a positive. 4 times 4 is 4 squared. Negative times negative is a negative. 4 times X is 4X. Positive times negative is negative. X times 4 is 4X. Positive times negative is negative. X times X is X squared. Well, this is positive 4X. This is positive 4X here. Negative times negative is a positive. The middle terms cancel. We're left with 4X minus X squared. It's the difference of two squares. Remember, it's the same thing as the rule we just had. This is the first term, it's squared. This is the second term, it's squared. Just subtract them. Whenever you have the same number, x and 5, x and 5, the only thing different are the signs between them. If it's x plus 5, x minus 5, they're just opposite signs. Then we know the answer is going to be square the first term, square the second term, and subtract them. So the answer to this one will be x squared minus 25. We can also use equations. X plus 3 squared minus x minus 3 squared. And still, this first term is squared minus the second term is squared. So if we work this out, we have here, we're working backwards now. So x squared, this term comes from the first terms here. So this one, x plus 3, x plus 3. One's plus, one's minus. And the second term, x minus 3, x minus 3. We're just going from this direction to that direction. It's called factoring. So since it's a difference of two squares, take the first term plus minus the second term. Now let's simplify. There's nothing in front there, so we don't need the parentheses. There's a positive 1, so nothing changes there. Leave the first term alone, it's positive in front. This one has a negative, so I got to multiply the negative to both of those. Negative times positive is negative x. Negative and negative is a positive 3. Combine like terms. X plus x is 2x. The 3 minus 3 cancels. So I have a 2x in front. X minus x, the x's cancel. 3 plus 3 is 6. Look at another one. X squared minus 9. Is this a difference of two squares? What's 3 made up of? 9 made up of? 3 times 3, so it's. Since it's a difference of two squares, we know it's x plus 3, x minus 3. And that's factoring. Two x minus or plus 8xy. What do both of those terms have in common? Well, since the first term is negative, we can take out a negative. 2. 8 is made up of 4 times 2, so they both have a 2 in common also. They both have an x, so I take out the x. What I'm left with is because I took everything out here, there's just a 1. I took out the negative, I changed this first term to positive, so I gotta change the second one into negative. I took out the 2, so I have 4, and I took out the x, so I have 4y. So negative 2x plus 8xy factors out to being 10. We took out the negatives, which means inside the parentheses, I changed their signs. So I took out the negative. I took out a 2 out of both of them. So I divided by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. I took out the x, so I divided by x. The x cancels, so there's no x. The x's cancel, all is left is y. And you can check your answer. Multiply these two together, you'll get that answer. Negative times positive is negative. 2 times 1 is 2, x. Negative times negative is positive. 2 times 4 is 8. X times y is xy. And that's exactly what we wanted to find. So we know this is the proper factor. What do these two have in common? Well, whenever you ask the factor, what is 9 made up of? 3 times 3. So we have 3x minus 3 times 3. What do both of these terms have in common? They have 1, 3. So I can take it out. If I take it out, I remove it. What I have left, I have the x minus 3. And that's that one. That's factoring. Okay, now let's finish up talking about division. Division puts numbers into groups. Remember, multiplication, we had groups. This is how many times we repeat the groups. Now, division puts numbers into groups. For example, 15 divided by 3. Let's look at the chip model. If I had 15 chips, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. These are the total number of elements. This is the number of groups they go into. So what I gotta do here, I gotta make 3 separate groups. And if it's divisible, they'll have an equal number each. So I take the first 3. 1, 2, 3. I take the second 3. 1, 2, 3. And the third 3. Then the fourth 3. And then the fifth 3. That's all of them taken care of. Each group has the same number, 1, 2, 3, 4, 5. So we know that 15 divided by 3 is 5. (16) divided by 4. This could also be written this way. This could also be written this way. Division has multiple ways of writing them. So again, the first number or the top number or the number inside here, that tells us the number of elements we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 elements. I need, or this tells us the number of groups. 1, 2, 3, 4. So there are 4 groups. I need 1, 2, 3, 4. I need these 4, 1 in each. 1, 2, 3, 4. I need 4 more. 1, 2, 3, 4. 4 more. 1, 2, 3, 4. And then there's 4 more there. There's no more chips inside the main group. So the answer is they all have 4. So all these equal 4. 16 divided by 4 is 4. Let's look at an example where it doesn't work. 15 divided by 4. There are 15 chips. 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need 4 groups. So I take out the first 4, 1, 2, 3, 4, and put 1 in each. Take out the next 4, put 1 in each. The next 4. But there's only 3 left. So since that doesn't work, we know that 4 doesn't go into 15, which gives us a remainder. But that's another topic right now. So in other words, these are not divisible. Eventually we'll write, since we have 3 in each group, we have 3 in each group and 3 left over out of 4. So that's what we're going to have left. These are remainders. And this is your denominator, the number of groups. We'll talk about mixed numbers later. How do we use a number line? For division. (15) divided by 4. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're still looking at here. Remember, this is the total number we have. We will put it in 4 groups. So put them in. Can we make 4 equal groups? Let's see. So if we put 4, that's 1. That's 2. That's 3. But that's not going to work. So it's going to be less than 4 groups. 4, and this is going to be less than 4. So we have now with 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, 3 works, but there's too many groups. So this doesn't work. You can't divide that. How about 15 divided by 3. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we'll try 5 first. And since there are 3 circles, and they each have 5 in there, and they can all 15 of them, we say that 15 divided by 5 equals 3. What about signed numbers? Negative 12 divided by 4. We have to look at the definition of division. It says for all integers x, y, and z, there is a unique number k, if it exists, such that x equals y times k. In other words, x divided by y equals k. There's some unique number that if I could find a number multiplied to the denominator, then division exists. Then you have a whole answer. If not, then you have a remainder, and that's another topic. Inequalities. Less than. How would we define the term less than? For all integers, x and y, x is less than y, written x is less than y, if and only if there exists a positive integer k such that x plus k equals y. For all integers x and y, x is less than k, written as x is less than y. If there exists an integer k, it's a positive number, that if we add it to x, then it equals to y. Here's an example. 3 is less than 5. How do we know that 3 is less than 5? Because if I added 2 more to it, then it equals. The examples here. There's a theorem related to that. 5-10. X is less than Y if and only if Y minus X is greater than 0 and X minus Y is less than 0. Let's look at this. 3 is less than 5. True if this is X and this is Y. If 5 minus 3 is greater than 0, that's true. And 3 minus 5 is less than 0. That's true. So that's how you tell less than. Conversely, simply you look at greater than. Theorem 5-11. X and Y are integers. These next 4 principles have to exist. If X and Y are integers, if X is less than Y, then X plus K is also less than Y plus K. For any number K, positive, where K is any integer greater than 0, greater than or equal to 0. If X is less than Y, then negative X is greater than negative Y. Three is less than 5. If I make them both negative, -3 is bigger than -5 because it's further on the right of the number line. If X is less than Y and X is greater than 0, not X, it's got to be some constant. Then N times X is less than N times Y. Perhaps if X is less than Y and N is some number greater than 0, it's a positive integer, then N times X is less than N times Y. C goes along with what A says. If I have a K that's greater than 0, then X plus K is less than Y plus K. Same thing, N, X times N is less than Y times N. If X is less than Y and N is less than 0, then NX is greater than NY, which is what step B tells us. Here's some examples. X plus 3 is less than -2. Simplify. How do we prove that that's true? What is X? How do we do that? Yes, you're right. But how do we do that? No, since it's positive 3, we add the negative of it, the opposite of it. Because any number plus its opposite equals 0. So we get rid of it by adding -3 to it. So 3 minus 3 is gone. So we have x. Oops, this is 3. They're both negative. 2 plus 3 is 5. That means x is less than -5. Negative x minus 3 is less than 5. We do the same kind of thing here. We have to get rid of the -3. How do we get rid of -3? Add 3, right? Put a positive 3 to both sides. But we cannot have a negative in front of our answer. Yes. So basically, all you do here is change the sign across the board. Change everything across the board. So negative, the opposite of negative x is what? The opposite of less than is the opposite of positive 8. Right. So whenever you have a negative in front of your x in your final answer, change everything. Get the opposite of everything. Last example. If x is less than or equal to -2, then to find an inequality for 5 minus 3x, we do what? In other words, x is less than -2. To find an inequality for this, I think I wrote that down right. So let's see, we know we have this, we have -3, negative, it could be equal. So the biggest it's going to be is +6. So that means -3x is equal to +6. So 5 minus 3x is greater than or equal to 5 plus 6. Yeah, so what we did here is, since we're saying x is less than or equal to -2, if I plug in -2 in place of x, this number here will equal 6. Because x is less than, so this is the biggest it can be. So that's the biggest it can be. So that means, since this is basically, if we started off with 5x, 5 minus 3x equals 5 minus 3x. We plugged in 2, we got 6. So this minus 3x is equal to 6. All right, equal to +6. But x can now be smaller than everything else, which means since 3 is negative, it's going to get bigger. What's smaller than -2? -3. So -3 times -3 is positive 9, so it's going to be bigger. So we're looking at 5 minus 3x is greater than 11. There's our inequality. And so as that's the smallest it can be is equal to 11. Then it could be, since this is the slope, it could be 14, 17, 20, 23, 26, and so on and so forth. Ta-da! End of chapter 5. Chapter 5 only had 2 sections: addition, subtraction, multiplication, division. That's it. We did those. So next time we're going to do chapter 6, which I think only has 3 or 4. So we're in very good shape to finish the semester within the next 3 or 4 weeks. Any questions?
First I was lost. I was wondering how you got 6, but then I forgot about the.
Yeah, because of this.
Yeah, I forgot about the 2.
That's called an initial condition. So we start off with what we can, which is -2.
And then I remember you got it from.
Exactly. But I don't think I put anything down in the homeworks because I hate those kind of brain busters. It's cruel giving that to kids.
No, I was always like fighting.
Yeah, so I mean, bottom line is, anyhow you can think of to teach kids division or multiplication works. Whatever works for you works for them. That's good. And that's the tough part, because what works for me may not work for you. Or if it doesn't work, then you have to come up with your own. And that's beautiful. That's the beauty of YouTube. If you're looking for ideas in the future, just pop up and just type in teaching division to 4th graders. And it'll give you that, or Pinterest. Pinterest is notorious for having millions of ideas. Okay, look, that's it for today. That's it for this. Today's what? Wednesday? That's it for this week. Have a good weekend, everybody, and I will see you on Monday.